Hello, my name is Dean Banerjee. I'm with the Texas Instruments High-Speed Signal Path Division, specializing in clocks and synthesizers. Today we're going to be talking about the LMX2581 broadband frequency synthesizer. This product can produce any frequency from 50 megahertz to about 3.8 gigahertz. It has a high performance PLL with a figure of merit of about negative 227 dBc per hertz. The phase detector on the PLL can go up to 200 megahertz, which allows the user the benefits of avoiding integer boundary spurs and also better PLL phase noise. The VCO, aside from being broadband, is very flexible. The device actually allows the user to select in software between internal VCO, external VCO, or use some hybrid combination of both. The VCO can calibrate in very fast time. With the proper programming and high enough input reference, it can calibrate in the order of 10 microseconds. Looking at our setup here, we have a power supply, phase noise analyzer, evaluation board. This is the LMX2581 right here. We have one of the differential outputs hooked to the phase noise analyzer. The unused side of the differential output is terminated with a 50 ohm resistance. This is the 3.3 volt power supply. We have a lock detect function on this device. On the board here, I have it hooked up to an LED. It's lit green to depict that the device is in lock. Here I have a 100 megahertz crystal oscillator, which drives the device. We also can use other things to drive this, such as the LMK2581 or signal generator through this pin. This is the programming cable going back to the computer. On the computer here, we have the 100 megahertz crystal oscillator. We're dividing this by 5 to get a 20 megahertz phase detector frequency. The output frequency is 2 gigahertz. The charge pump gain can be programmed anywhere from 1 to 32 times state. This allows the user the flexibility to compensate for differences in the VCO gain. The fractional denominator is fully programmable from 1 to 4194303 and anything in between, and of course the numerator is programmable as well. If we look into the bits and pins tab here, it gives us insight into some of the features. We have power up and power down modes, different modes, external, internal VCO. We have a channel divider, which allows us to get to the lower frequencies, various settings to optimize the charge pumps for the fractional spurs, fast lock controls, fractional settings for the modulator, such as dithering and also programmable modulator order. We have lock detect pin settings. We also have the VCO frequency calibration settings. The 2581 has 4 cores in its VCO, which it automatically picks whenever the frequency is changed. The way that it picks it can be set by this particular programming bit. You can choose to pick the last VCO selected, which would be good for small frequency changes. You can also choose it to start with a VCO selected, and this would be good for large frequency changes, and also is very useful to get the best possible lock time. You could also force it if you want as a diagnostic. So looking at the high performance VCO, if we look over here at our phase noise analyzer, just for example, we're doing better than 137 dBc per hertz at 1 megahertz offset. Another thing of interest might be the output power. Right now, this single-ended output power is about 6 dBm. If I program this to the lowest possible setting on the output power, which would be the setting of output power equals 0, I get negative 2.5 dBm. If I go to the highest possible setting of 45, it's going to give me an output power of 11.8 or just about 12 dBm. That's some very serious output power. And remember, this is a single-ended, not differential, single-ended output. Also, even if I go to, say, 3.7 gigahertz, if we go to 3.7 gigahertz, we're still doing better than plus 10 dBm right there. So the code loader tool is what I've been using in this demo today. It runs the LMX2581, but actually can run all of our LMX and LMK devices. We have other tools available, such as the National Clock Design tool, which allows the user to design your loop filter and also simulate the performance. So this can actually simulate phase noise and fractional spurs. It can give you insight into the impact of the fractional modulator order and the dithering. I hope you guys had a fun day in lab today. If interested, you can visit our website at www.ti.com/LMX2581. There we have the clock design tool, code loader software, data sheet. We have the evaluation board instructions, which has the schematics and has the components and measured data. And we also have other interesting app notes, including my PLL book. Thank you for tuning in.